all new Action One Network. Turn up your volume.
Hi, my name is Shinga, and I'm the host of SG2 on Space, the only weekly space show here in Houston. Based here with Action One Media Group support in their studio every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. You know, all that cool jazz, and occasionally about aliens as well. Um, so STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me. And I feel like Action One Media's goal is aligned with mine. So together we hope to encourage the knowledge and especially the passion and interest in outer space in our Houston community and beyond. Excuse me. Oh man. So, this is me, your host Shenga, SG2 on Space, the only weekly space show bad grammar, in Houston, I would like to say. Today is episode number 51. Yes, I've done this for over a year now. Imagine that in the lovely Action One Media studio here. You can see that. So weareA1.com is the website. Now, please follow me at facebook.com/theshenshow. Also, that's it. It's linked to the YouTube directly, all right? So I don't need to tell you that. Now, I do have to say, the show does cost studio time and productive and money, let's just say, to produce. So I would highly like it, if you like this show, to go on patreon.com, patreon.com/SG2 on Space and support me. All right, so that's patreon.com/SG2 on Space. Patreon is a website where creatives, get supported. So go there. I will say it a few more times throughout the show, and I'm sure somebody will listen one day. All right, so today I figured we would
dive into physics of the universe or cosmology. That would be the theme. Once again, I'm going to have Mr. Leonard Kramer online in a bit. He and I actually, we talked about some space stuff, cosmic microwave background, expansion of the universe. So he has definitely some background in that. So I want to ask him a few questions, and we'll just have a back and forth later. But for now, first of all, before we get to around the 8:30 mark, let's talk about some calendar of events coming up globally. So we got New Space Europe 2019. That's next Wednesday and Thursday at none other than Luxembourg. Mentioned this last time. Luxembourg is a tiny little European country that's aspiring to be the center of, new space and, in the world. So they have this conference called New Space Europe 2019, located at 4 Place de la Europe, Luxembourg, L-1499, Luxembourg, European Convention Center, Luxembourg. Okay. If you're interested in signing up, it is newspace-europe.lu. Now, like I said, it is all the way up in Luxembourg, which if you're living in the U.S., then that would mean booking a plane ticket really fast for next week, okay? So if you haven't planned it already, might be a little too late. But it should be interesting. I mean, they got some major European companies as partners, SES, as well as ESA, of course. So that aside, another one that might be of interest to you is the International Summit on Physics and Astronomy, for those of us more attuned to astronomy and space physics. And that's from November 14th until November 15th. And where is this? Osaka, Japan. So once again, I hope you booked your tickets, or maybe you're already there. Okay. Now, closer in to home, there is a New Worlds Conference, New Worlds 2019 in Austin, Texas at the Bullock, Bullock, Texas State History Museum. That is Friday, November 15th, starting at 8 in the morning until Saturday, November 16th at apparently 1 in the morning, unless I'm mistaken. Unless it's 1 p.m.? I don't know. But point is, what is going on here? Well, November 15th and 16th in Austin, Texas, world-class scientists, experts, engineers will join the newest minds and future leaders to explain, discuss, and debate the challenges and solutions we face in space. Entrepreneurs and financial experts will talk about new businesses and ways to pay for these new opportunities. Astronauts will tell us what it's like out there. Artists will show us what it will be like tomorrow. Makers will show how they will make what we need to live. Okay, and so on and so forth. So it's promoting itself as this very Renaissance lady, woman, man. Okay, point is, you could be an artist, you could be a musician. In fact, they have musicians invited there. You could be an entrepreneur, whatever else, right? So I'm not saying it's cheap. It's still like about $300. Apparently, the tickets, at least they advertise it, if you're a woman, that's right. If you're a woman, it's free. So guys, go change your sex. I'm kidding. Don't do that. That was a lame joke. But point is, I found this so interesting. Like, yeah, if you're apparently female, it's free. So, that's kind of interesting. So I know the founder of this. Actually, I invited him to he was a keynote speaker at a conference I organized back in 2012 on the Isle of Man. Rick Tomlinson, actually, he is the founder, of this organization that is organizing this. He's the founder of Earth-like Foundation / New Worlds Institute / Space Fund. So Rick Tomlinson is going to be there. Just to note, he was also a co-founder of Deep Space Industries, I believe, before I think he sold them or something. All right. So Buzz Aldrin is going to be there. Buzz Aldrin, second man on the moon. Also Cass Anvar, who I don't know if you ever watched The Expanse for sci-fi fans out there, but he co-starred in The Expanse. Okay, so all right. Moving on. There's also a Summit on Space Innovations Conference that is on Monday, November 18th. This is not in Texas, but it's still in the U.S. This is at Georgia Tech at the Marcus Nanotechnology Research Center. So if you're in Atlanta or you happen to be there or want to go there, it's free. So check it out, okay? I'm originally from Georgia, but I'm not going to be there at that time. So anyways. Okay. Once again, hopping across the pond, there is a Space Up Leicester 2019 conference, or unconference rather, that's in the UK on Saturday, November 16th. And that's only $25, and that's basically anybody could participate. It's an unconference, right? It's open to the public. User-generated conference. We had one back here in Houston a few years ago. Okay. Then in Houston, if you don't want to travel anywhere and you live here, or you're coming to Houston, you want to come to Houston, then SpaceCom 2019 is one of the largest commercial space conferences in the U.S., and that is on Wednesday, November 20th, 7:30 a.m., starting from 7:30 a.m. until Thursday, November 21st at 9 p.m. at the George R. Brown Convention Center. And you can still sign up at spacecomexpo.com. spacecomexpo.com. And I believe if you work down at NASA here in Houston, down in the Clear Lake area, they have free buses that would take you to George Brown Convention Center, which is in downtown, and back. So this is for the commercial space industry. So it's going to have a lot of big companies, little companies, and NASA, of course. So also, you know, there's there's an entrepreneur summit. So if you're an entrepreneur, that might be cool. You know, there's a global spaceport alliance, and so it's pretty cool. So yeah. Lastly, to note, the exhibition hall is actually free, so you can come and just go in the exhibition hall, see all the different companies. The actual conference, though, it does require you to pay, like, most of these conferences are fairly expensive, at least a couple $100s. All right, so just a note. In any case, so that's all for what I see is coming up. We're gonna have to take a little short break. When we come back, I want to go over a few things, notably the three-body problem. Apparently, artificial intelligence can solve that very quickly. Galactic fountains formations, how erratically moving giant planets, it could still be okay for life for some of these other planets, and some other stuff. Okay, so we're going to talk about that. All right, so we'll take a short break.
You sitting on the internet all day. Why not go ahead and fill out our survey? Man, you still here? Go on and subscribe. Man, you still here? Go ahead and fill out our survey. Some of the other things you got going on.
Absolutely. So thank you for having me. I feel like I'm the presence of like celebrity.
It's just a shades, man.
So I think like 2000.
Growing up as a black kid in New Jersey, all I ever wanted to do was be a pro athlete. All of my role models were black athletes. And every time I would stare out the window and look at the sky and wonder what I'd be in the future, it always had to do with me catching some crazy football and scoring a touchdown. When it came to the point that I was told that I would not be able to play on an organized sports team for the rest of my life, it was something that I really didn't even know how to stomach in the moment. And I remember walking out of my cardiologist's office and just sitting in the hallway and breaking down for a few minutes just because it was something that I just couldn't plan for and couldn't account for. And I realized that in that moment, my entire life was going to be changed. And all of those dreams and hopes and aspirations that I had were going to go out of the window.
All right, we're back. So, first of all, before I talk about what you just saw, SG2 on Space, episode number 51. Today we're talking about physics, notably physics of the cosmology, as well as actually star systems, all right? So, we'll start out more on the smaller side. Oh, episode 51, follow me, facebook.com/The Shen Show, support me, patreon.com/SG2 on Space, number 2, okay? Not TWO. So, with that out of the way, let's talk about what you just saw. So, three-body problem, what exactly is that? Well, it is actually one of the hardest problems in physics, Newtonian physics, all right? Newton was the first one who formulated it, or first one according to historical accounts. So, two-body problem is literally, say, the sun and Earth, okay? Earth goes around the sun, gravity, right? Or general relativity, whichever one you want. Now, what if you have sun, Earth, and moon, okay? Moon's affected by Earth, also affected by sun, but Earth also affects the sun, Earth affects the moon, moon actually affects the Earth, and moon affects the sun. It turns out that's actually an incredibly difficult problem to solve. So the gravitational, and then considering adding all the other planets and moons in our solar system, the gravitational interactions between three celestial objects, just three, it doesn't even have to be 4, 5, 6, 7, 8, 9, 10, whatever. It results in a chaotic system. So chaotic system is highly sensitive, it's highly complex, and really sensitive to starting positions, initial conditions of each body, all right? So currently, to solve these particular problems, we either do approximations by using some perturbation theories, for instance, the moon and the Earth, right? We're going to assume that, okay, Earth is going to dominate the local gravitational field related to the moon, and vice versa. So we're going to ignore the sun, or just pretend the effect is negligible, okay? Until you get to a certain point, then you consider the sun. Okay, if you really want to be accurate, yes, there's software that can solve it, but it could take weeks or even months to solve, which, you know, is quite computationally expensive, right? So what did researchers do recently? Well, they decided, oh yeah, what you just saw were some examples of how initial conditions can change these orbits into all sorts of weird configurations, right? You saw that in that video. Apologies, I did not have sound. So, in any case, so what did researchers recently decide to do? They decided to see if neural networks, which is a type of artificial intelligence, so pattern recognition, right, could figure out how, you know, whether it can predict where these orbits would be, right? So it turns out that the algorithm the scientists created provided accurate solutions up to 100 million times faster than the most advanced software program called Brutus. All right? So this is invaluable to astronomers to try to understand the behaviors of, like, say, star clusters or broader evolution of the universe or even star systems, right? So you can read this paper. It's by lead author, I believe it's Chris Foley, Foley. He's a biostatistician at the University of Cambridge and co-author of the paper. Look it up in the ArXiv database, ARXIV, very good database, by the way. So he says this neural network, this neural net, if it does a good job, should be able to provide us with solutions in an unprecedented time frame. So we can start to think about making progress with much deeper questions, like how gravitational waves form. All right, so it's fascinating, right? So they tested how the evolution of 5,000 unseen scenarios and try to match those with Brutus, right? The most capable, most advanced software program today. And guess what? The AI-based software program solved the problem in an average of just a fraction of a second compared with nearly 2 minutes per Brutus. Now, that may not sound like a lot in difference, but imagine if Brutus takes, like, I don't know, 100 hours to solve. Then fractionally 100 hours, divide that by what? Divide that by 120. So it's like 120 times faster, all right? So, any case, go read the article. That's what I got to say. It should be really interesting. All right. Second thing. I gotta say, erratic giants are actually okay for life. Now, what am I saying by that? So there's exoplanets out there, Okay, let's backtrack. For a long time, we have thought that astronomers have thought that if you have a gigantic planet in a really erratic, meaning weird orbit, right, in a star system, then it is going to preclude, in other words, prevent the presence of life for an Earth-like planet in the same solar system, same star system, or life on that planet. So why? Well, we assumed what's going to happen is that the unstable orbit by this gigantic, like Jupiter-sized or even larger planet, will make this habitable planet going in a weird way, or even be flung out of its star system, in which case life will not develop, right? Because you're flung out. Well, guess what? Some astronomer, Stephen Kane, who's associate professor of planetary astrophysics at UC Riverside, and Caltech astronomer Sarah Blunt tested the stability of an Earth-like planet in the HR 5183 solar system. You can read it up on Astronomical Journal, and they calculated giant planet's gravitational pull on Earth analog. And guess what? In certain parts of the planetary system, actually, the gravitational effect of the giant planet is small enough to allow the Earth-like planet to remain in a stable orbit. And they also found that this the best chance of remaining in a stable orbit for this smaller terrestrial planet is within the habitable zone, which is a territory around a star that is warm enough to allow for liquid water, oceans on the planet, right? So this finding basically increases the number of places where life might exist in the solar system, which is kind of cool. And yeah, so, you know, going ahead, Kang and his colleagues, they're going to continue studying planetary systems similar to HR 5183. They're currently using NASA's Transiting Exoplanet Survey Satellite, which I've mentioned a bunch of times on these shows, tests, and the Keck observatories in Hawaii to discover new planets, all right? And look at the diversity of possible orbital, I guess, positions under which planets could be possibly habitable. And habitable, having life, and thriving. So, all right. So another kind of simulation on a larger scale, there is recently article that I saw on phys.org that scientists from Germany and the U.S. actually have unveiled the results of a newly completed state-of-the-art simulation of the evolution of galaxies. The TNG-50 apparently is the most detailed, large-scale cosmological simulation yet. Allows researchers to study in detail how galaxies form and how they have evolved since the Big Bang, which is really cool, right? So it has revealed that the geometry of the cosmic gas flows through that flows around galaxies determines the galaxy structures, and also vice versa. So, okay, you can read these two papers in the journal Monthly Notices of the Royal Astronomical Society. Now, what is so special about this? Hasn't it been this done before? Well, it's true that other large-scale simulations have been done, but it turns out that, you know, there's a trade-off between how much computing power you want to put in and how accurately you want it to actually be, right? So detailed simulations with limited volumes, you can't model more than just a few galaxies, all right? Large-scale simulations, though, like the universe, you can't like narrow down into small-scale properties. So this simulation avoids this trade-off. So it combines a large-scale cosmological situation, universe in a box essentially, with the computational resolution of Zoom simulation, which is pretty cool, all right? So it has a space that's more than 230 million light years across, and it can discern physical phenomena on scales that's 1 million times smaller. So you can trace the simultaneous evolutions of these galaxies over 13.8 billion years of cosmic history, which is our predicted age of our universe, all right, estimated. And there's 20 billion particles representing dark matter, stars, cosmic gas, magnetic fields, blah, 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 blah. It does require a Hazel Hen supercomputer, so sorry, you can't really run this at home, guys. Nope, it's not like you can download it and run it. Just going to have to trust the simulations. All right. So, in any case, it's really cool. So go look it up, and you'll see some amazing galactic simulation images, which should, you know, match reality or the structural reality. You can go backwards in time, see how the galaxies were like 10 million years ago. Crazy stuff. All right. So that is pretty darn cool. Now, keep talking about simulations, but what about real life? What's going on? Well, guess what? I like to talk about something that happened with Hubble recently. Hubble has recently captured a dozen sunburst arc doppelgangers. What exactly am I saying here? Well, astronomers using the Hubble Space Telescope have observed a galaxy in distant regions of the universe which appears duplicated 12 times on the night sky. So you might be thinking, okay, there's 12 different galaxies? No, these are the same galaxies. Now, how does that happen? Well, it's through a phenomenon known as gravitational lensing, right? So what is gravitational lensing? Just a brief summary. You know, Einstein's general theory of relativity, right, says that gravity bends light. So if gravity bends light and you have, okay, so say I'm watching camera here. So say you're watching me. If you have a massive object here, the light, you know how you see something is light enters your eyes, right? So typically, light may enter like a straight. So I see just one image of me, right? But if it bends, you're going to see light coming from two sources because our eyes automatically assume that it is straight. Even when light bends, you assume that it's straight. So say this is a massive gravitational body here. Then the light would be, and I'm a shining star. Yes, exactly. So the light will go bend like this, and it will also bend like that. So you will see from your perspective two different me, all right? Two different shins, all right? You get it? Now, if you have more and more, light could bend apparently into, 12 rays. And so what you will see is that 12 mirror images of the same thing, okay? Which is pretty darn cool, right? So this the galaxy, by the way, is nicknamed Sunburst Arc. Sunburst Arc, ARC. It's almost 11 billion light years away from Earth and has been lensed into multiple images by a massive cluster of galaxies 4.6 billion light years away. So instead of one thing doing that, just imagine now another one. So gravitational lensing a bunch of times. Now you see like 12 of these, right? So go look it up. It is absolutely beautiful. I mean, the universe is beautiful, guys. So, all right, you will see that. All right, so I think it's time for a cosmology segment since we're already in it. Okay, I am going to bring in my eccentric co-host for a little bit. Let's just say, or guest, I should say, Leonard. He will join us shortly. So just a note, if you guys watched last week's episode, which was Halloween, I had Leonard on. We talked about really weird things. This time, given our theme, I figure we're talking about, some seemingly more legitimate matters. Notably, want to actually have a background on the background of the universe. So there is a phenomenon, not a phenomenon. There is something known as the cosmic microwave background, all right? And I want to talk about that or ask Leonard about it because that directly relates to why we think the universe is as it is, like the Big Bang say, and how old it is, all right? It was actually one of the greatest proofs of the Big Bang. So what exactly is it, right? Are we able to get an answer for that? Is Leonard, are you on?
Hi, Leonard. This is Miles Monroe.
Can you even hear me?
I was watching the show.
Leonard, are you on? Is Leonard, are you on?
Hi, Leonard. This is Miles Monroe. Oh, my God.
You might want to turn down your volume. This is interesting. I have no idea why the phone's ringing, but for the sake of people actually watching, let me just go over what the CMB is until we get this sorted out. So cosmic microwave background is basically electromagnetic radiation that's left over from the beginning of the Big Bang. All right. So it is also known as relic radiation, RELIC. So what is it? Well, it's a landmark evidence of the Big Bang. Now, why is that? Well, when the universe is young, before the formation of stars much hotter and filled with like this uniform glow of this amazingly hot fog of hydrogen plasma. Okay, so what we see today as a cosmic microwave background is simply this light, this radiation that's been cooled down. All right, it's been cooled down over billions of years. So what is interesting is that this was it has a very small amount of variation, but it does have variation. All right, and its emission, it matches a black body thermal energy. So Leonard, do you know, can you provide some more insight into that?
Hey, just coming on.
If you happen to be listening. Okay, or I can go provide that insight. All right, so in the Big Bang model of the formation of the universe, at 10 to the negative 37 seconds, the universe underwent exponential growth that smoothed out nearly all irregularities. Okay, so in any case, what do you So, Leonard, I recall we had a brief conversation of the cosmic microwave background. So, how would you describe it?
Hey, Shen.
Hey, first of all, hey.
Had some technical difficulties getting connected. I would say the microwave background is an image of the Big Bang at 380,000 years after the event. It's the point in time when the universe had cooled to 3,000 Kelvin and the protons and electrons had started to combine with each other and the plasma became transparent. And so those are photons that are left over from that epoch. They started out at around 3,000 Kelvin. They were orange. The whole universe was orange. And now with the expansion of the universe over the past 13 billion years, surface has become redshifted to a very cold temperature that corresponds to an emission in the microwave band. So it started out orange, and after 13 billion years, it's now microwave. So it got Doppler shifted through that orange color to red, infrared, microwave, and so now it's a surface that's every place you look at that band in the universe, you see this noise, and it corresponds to a temperature of 2.75 and some other digits, and it's totally cool.
It is very cool in multiple meanings of that word. So it is 2.725 kelvins, which is just slightly above absolute zero. So, guys, for the explanation for the general public here, so Doppler shift essentially means that it's a change in frequency of a wave in relation to observer when the wave is moving, say, away from the observer. Okay, so just to know, if you guys hear a police siren come and then go away and you hear the pitch change, well, that's due to the Doppler effect. Same thing happens with with light. So and also the fact that our universe is expanding, right? So that's what's going on here with this shift. Okay, so why does the cosmic microwave background, is that an indication of the Big Bang, Leonard?
I would say that it's very compelling evidence that there was a Big Bang.
Okay.
It's also a very precisely tuned black body. I read somewhere that it is the most precisely measured black body that is observed in nature, and that's quite remarkable for something that is 26 billion light years in diameter. So the little fluctuations that are seen in that on that surface seem to correspond to quantum mechanical fluctuations that were occurring at the point when the universe became at the point when the universe was had an origin. There is more to it than that. I mean, beyond that point is not observable because it's opaque. But we can postulate that if you keep going further back in time and looking further behind this black body, this microwave background surface, there's a point where the Doppler shift is to 0 Kelvin. It's at absolute 0, and it has the characteristics of sort of an inverse black hole. So it's as though we exist inside of a inverted black hole, and there's a postulated surface at 0 Kelvin where the expansion of the universe is at the speed of light, and beyond that we don't know. We don't have any physics.
Wait a minute. You said that the universe is possibly described as an inverted black hole?
Yeah. Because there's some analogies to what happens on a black hole. You know, that's a surface where light cannot escape. Well, there is a surface beyond the microwave black body, microwave
background.
There's this point where the expansion of the universe is so great that it's expanding faster than the speed of light, and we should expect that surface to be at 0 Kelvin. Nothing escapes. You know, we can't see anything beyond that because space is expanding faster than light, and so it has the same kind of character as the surface of a black body, except that it's the reverse.
It is a reverse, right?
It's reverse. Also, time has stopped on that surface. Time there, you know, so everything that had ever occurred at the instant of at the Big Bang is frozen on that surface.
When you say frozen, what do you mean by that? Like when we see it, it is exactly what that looked like back then?
Yes, it's exactly what the Big Bang would have looked like. All of the information that existed at the time of the Big Bang should be impressed on that surface. And because it's expanding at the speed of light, the time stops, and nothing is changing.
Wow.
Yeah. Wow. Now, at this moment, that's as we would apprehend it from our point of view. You know, where it is at the current time, things are happening. Right? But we can't observe that because it's expanding faster than at the speed of light. I don't really want to say faster than the speed of light, but actually, beyond that, things are expanding faster than the speed of light. There's no problem with that with special relativity because it's actually the space itself that's expanding.
Right.
It's not the propagation of anything. So I just thought I'd throw that out there because it's pretty wild.
That is pretty wild. Okay, so let's just say 100 million years from now, or 1 billion years from now in the future, okay, our ancestors, not our ancestors, our descendants. Let's just say they look out and look at the cosmic microwave background. Would they see something different?
On the cosmic, the microwave background, time has not stopped. Things are still occurring there. But on that surface, that postulated surface, theoretical surface beyond 380,000 light years beyond, beyond that, nothing. You would not be able to apprehend that anything was going on.
Okay.
However, at this moment,
Mm-hmm.
things are going on. In other words, it continues to evolve, but we can't see it. We only see something that's Doppler shifted infinitely black.
Okay, very interesting.
It's more interesting, but maybe for another time. We can talk about entangled variables and the holographic universe.
Right. So actually, speaking of the universe, I think I told you to. There was a recent article about the axion particle. Have you heard of that?
Yeah, I actually did read that. I mean, you sent me a link, and I looked at that. I had actually seen that earlier.
Okay.
So this is something that has to do with dark energy.
Right.
And dark energy is we mentioned the expansion of the universe. Recently, within the past, I guess 5 to 10 years, different ways of measuring the expansion of the universe are giving different answers.
Yes.
And it's looking very much like the expansion of the universe is increasing. So younger things that are closer, are not expanding as fast as things that are further away, and it's not accountable for just a larger distance. So there is an actual increase as a function of time of that Hubble expansion, and that's the origin of the theory about dark energy. The dark energy is very interesting. And so it looks like, from what I can tell about this axion
Mm-hmm.
particle, they're trying to postulate that there is one of the quantum fields
Mm-hmm.
might account for both the dark energy and connecting it with dark matter.
That is correct.
I kind of think that's possible. Dark energy and dark matter are generally, if you ask people, like
Mm-hmm.
other people in graduate school, other scientists, they're going to tell you dark energy and dark matter, as far as we can tell, are separate phenomenon. And really, dark matter is kind of misnamed. It really should be called dark gravity, perhaps. But
That sounds way cool.
they are separate kind of things. Basically,
Mm-hmm.
dark energy accounts for this acceleration in the Hubble expansion of the universe.
Mm-hmm.
And dark matter is something that has to do with some anomalous mass that's associated with galaxies and galactic clusters that explains an anomaly in the rotation of galaxies and gravitational lensing. I guess maybe your listeners know that light bends in
Yes.
the presence of gravitational
Yes, I
fields.
explained that earlier.
Right. So that's dark matter. It's very compelling. It's not. Please, don't think it's just like, oh, there's something black out there we can't see. Big deal. It's something very much more profound than that, and there's very good reasons for thinking it's not just something that's dark that you can't see. It's really some other component, unknown component of the universe that we don't have any understanding about. I'm kind of wandering around the topic, but I'm so excited about it that
I completely understand. So to summarize for listeners and viewers, what Leonard is saying is that dark matter is different from dark energy. For galaxies to be able to rotate and move the way it does, it has to have more mass, and hence there's something called dark matter, which we don't know what it's made of, but it has mass. And basically, it helps galaxies and other stars to clump together, and it also literally could also gravitationally affect light, so we know it has some mass. Dark energy, on the other hand, affects the expansion of our universe. Hubble expansion, named after Edwin Hubble, the astronomer who first postulated the universe is expanding, which it is. So dark energy gives the explanation of the universe, why it's expanding at a faster rate. Do we know what it is? We don't. There are certain particles, such as possibly the theoretical axions, which creates quantum fields that may be related to the changing dark energy. But it's still unknown until we discover these particles and learn more. So with that, we got to take a break. When we come back, let's continue a bit of this conversation, and then I got to tell you about aliens.
Lovely.
You sitting on the internet all day, why not go ahead and fill out our survey? Man, you still here? Go on and subscribe. Man, you still here? Go ahead and fill out our survey.
Yo, we back at it again, baby.
What?
Get into action.
3.
Get into action.
Tell me what is the deal, tell me what is the deal.
So I challenge you today to start strong.
Get into action.
Tell me what is the deal. Cause I'm calling for you.
Get into action.
Can you feel that? See, I'm calling for you. Can you feel that? See, I'm calling for you. Can you feel that? See, I'm calling for you. Say how you really feel.
This is a Wiz production.
When the 7 trumpets sound, we gon' start the revolution. When we turn up, we shut it down. We are skywalkers. The spheres of my Kabbalah, illuminated properly in sight, shows the man in universe and the creator's gift of life. When the earth collides with every piece of star from afar.
Hi, my name is Shen Ge, and I'm the host of SG2 on Space, the only weekly space show here in Houston. Based here with Action One Media Group support in their studio every Thursday night. So, my goal here is to educate the public in terms of space science, space flight, physics, astronomy, etc. You know, all that cool jazz, and occasionally about aliens as well. So STEAM education, science, technology, engineering, arts, since that's part of the creative aspect, and mathematics is very important to me. And I feel like Action One Media's goal is aligned with mine. So together we hope to encourage the knowledge and especially the passion and interest in outer space in our Houston community and beyond.
All right, guys, we are back. This is episode number 51 with your host, Shen Ge, S-H-E-N, last name G-E, SG2 on Space. Today we're talking about physics of cosmology. Oh, by the way, follow me, facebook.com/The Shen Show. Support me, patreon.com/SG2 on Space. So right before we went to break, I was conversing with Leonard Kramer on the cosmic microwave background, as well as dark energy and dark matter. So Leonard, have you also thought about the shape of our universe? Is it flat, or is it a sphere, or what is it?
You know, the article is a little bit clickbaity. You sent me an article on phys.org. They don't mean flat in the sense that like they want people to zero in on, oh, they must be talking about a flat Earth or something like that. They're talking about whether what we call flat space, meaning structure in the I don't think there's anything that earth-shaking about this article you sent me. There are various models of the universe which posit that if there's enough mass in the universe, then you can expect that a straight line that goes out forever, for example, will then return back onto its origin. So that's just something that's postulated. But as far as I'm concerned, the universe is really only goes out to that 0 Kelvin surface that I mentioned. So we can't really say anything about that. That the article that you referenced be missing a lot of things as far as I can tell. I just don't know how to comment on that.
Okay. Yeah. No, that makes sense. I've always presumed that if you go in one direction for long enough, you will come back to where you were. But
that's okay. Well, if there's enough mass in the universe, then you would expect that there would be a curvature that's curved, and that if there's enough, then it will curve back on itself. As far as it being flat, it being flat space, I don't think that was ever in the cards. We know that space is curved.
Okay.
So.
Huh. I'm gonna have to read this and actually understand what. Yeah, you're right. This article is somewhat of a clickbait. So. Okay.
Yeah, I mean that's the best I can do for you there, Shen.
No, that's good. All right. Now, Leonard, what is your view on the? Okay, you know what? Let's play this actually. Let's see if we can play this. Right. There's a video. Of these unidentified flying objects that was right off. Okay, we're going to aliens, guys. Just to know.
Do it.
All right. Enough.
When
of
you
this
saw your dad
stuff.
working under the hood.
So there's this video at Outer Banks, North Carolina, essentially of a mysterious group of lights. Hopefully we can get it on the screen soon. In the sky, and it was captured by a man visiting the area. It's gone viral on YouTube, like over 400,000 views now, I believe. And the question raised is, as always, is it aliens or is it the military? Or is it hallucination? It's not a hallucination. All right. Since it's captured. All right. So this was on by Williams Guy on September 28th, 2019. And it shows what appears to be 14 glowing lights hovering motionless over the water. So let us see it.
Nothing in the sky at all. And then all of a sudden,
Okay, so yeah, apparently the Marine Corps Air Station nearby said that there was no aircraft from the Air Force Base in the area the day it was posted. So what is it? And how are these lights just hovering there if it's not the military? And what is going on? Leonard, what do you think?
I don't know, Shen.
Okay. That's a very good answer. That was so great. Yeah.
I don't know.
I don't know either. That's
my mind is open.
Something's going on. Yeah. Well, I mean, I wish that I am fast enough to take out my camera to observe that. I'm just very bad at it because I saw something the other day and I was like, okay, too late. Can't even capture it. But point is, I mean, stuff like this happens, I suppose, quite frequently. But do we know what it is? No. And I don't know what happens after this. Do the lights disappear? Do they just dart off somewhere? I don't know. So for you guys interested, though, if you see anything, Leonard, if you actually, for anybody, not just, but there is a, what is it? You can report your sighting, if you wish. You can go to the MUFON, MUFON.com. That's one place to do it. So another one is the National UFO Reporting Center. That is at NUFORC.org. And that one's always cool. So reporting center, that is. Yep. So there's two different ways to record that I know of, where you can record your sightings, even if you don't have cool videos like this guy. You can go to MUFON.com. That's a mutual UFO network, and then click report your UFO observation. Or you can go to the National UFO Reporting Center at NUFORC.org and go report it there. So, and you can, put your time, where you are, the duration, descriptions, and all that jazz. So that's, yeah.
So did you ever see one?
Yeah, I saw one like 3 weeks ago.
Yeah.
Yeah, it was like something that was, it was a really bright, I think it was some kind of vehicle that had two really bright lights, and it appeared, I don't know, I noticed it, and then it was like, okay, this is a plane, but it wasn't a plane, because it like hovered there and then it moved away super fast, so it disappeared in like seconds. And then there were commercial airplanes around, and they were moving really slow, right, like they typically do. So I don't know what it was. I mean, it's definitely an unidentified flying object. Is it aliens? I don't know. Could be. So yeah. That's why I gotta say, you always have to look up. All right.
Yeah.
Okay. All right. So. All right, Leonard. I think we're gonna conclude the show. So thank you for your time on here, and I'm sure we can get you back on again if you're interested. So I'll talk to you about that off air. And for anybody else listening, everyone, okay, this is SG2 on Space, episode number 51. And today we were talking about physics of the cosmology, the universe, essentially. And follow me, facebook.com/The Shen Show, and support me at patreon.com/SG2 on Space. Also, you can find me on YouTube if you just search for SG2 on Space. Thank you, Action One Media Group, here in the studio. And before I go,
if you are currently calling in the SG2 on Space show, let you know that we are working to ensure that the show has a better time for calls. At this time, we can only host a certain number of calls at the same time. However, in the near future, because other people have been calling in, we will allow multiple calls. So we will get back to you guys on the show later about that. But we appreciate all of your support for SG2 on Space, and we hope you continue listening so that we can continue to grow into space and beyond.
Okay, cool.
Indeed. Wonderful. That was a much better voice. That was not my voice, by the way, for you guys who are not aware that I can't do sudden voice acting shifts. All right. So with that aside, yeah, follow me, facebook.com/The Shen Show, and thank you. And also, never forget, look up, because you never know what you will see. All right, peace out.
Cool. Good night.
Peace, it's Brother Atum Ra, and you tuned in to Action One Network.